Welcome to solverfy.
Okay, so the circuit given in the figure can be transformed and made a simpler from like this, where I have replaced this whole bunch of resistors at the top, this bunch of resistors here. So this whole bunch of resistors with 10 ohms, right? So I have replaced that. Now, how I did that? Because here 10 and 20 are in series, and 60 and 60 are in parallel, and 30 is in parallel, right? So if you look closely, so this is 10 plus 20 are in series, so they are 30, right? So that is 30 ohm, and below that 60 and 60 are in parallel. So if there are two resistors that are equal and they are in parallel, then the equivalent resistance would be half of that, so that is 30, and below that there is again one 30 ohm resistor. Now if we have three resistors which are in parallel and they are equal, then the equivalent resistance is one third of individual resistance, right? So one third of 30, this gives me 10. All right, so this is how I replaced this whole bunch of resistors with 10 ohm and made a simple circuit here. Now with this circuit here, we need to determine the value of E, what must be the EMF E, and we also see, look, if the EMF is good enough, right? The polarity of EMF is correctly shown in the figure, right? Okay, now, so how to do this? To do this, let us start by considering a loop. Considering a loop, let us consider this loop inside the small one, right? Like this. So for this loop, there is only one battery. So it's okay. Before that, I need to mention about the current. So the current 2 ampere is given here. So this current flows like this. 2 ampere goes like this. Now let us consider I current flows this way. So the remaining 2 minus I flows this way, right? So 2 minus I and I meet here, and again 2. So that goes this way, right? So for this loop, there is only one battery. So EMF E, and now the potential drop is, if you go along the loop, there is 2 minus I that is along the loop. So 2 minus I times 20, right? Yeah. And if you go a bit ahead, then there is 15 ohm, which has a current of I, but in opposite direction of the loop. So it is minus I times 15. Okay, so this is for the first equation that comes up due to the smaller loop. Right now, let us consider another loop, considering this 5 volts to be positive. So consider this whole loop, the outer loop. Okay, we are neglecting the inner 15 ohm and EMF E, only the outer loop. So for the outer loop, there are two potentials. We are considering 5 to be positive, so 5, and 10 is facing opposite to 5, so 5 minus 10. Right now, let's move on to the drop of charges, drop of voltage. So first the 10 ohm, 5 ohm, so 10 and 5, both of these 10 and 5 ohm resistor get 2 amperes. So first I can write the current is 2 and the potential drop across 10 and 5, that is 15. So let me write that individually. 2 into 10 plus 2 into 5, right? Now if you go ahead, so there is a 20 ohm resistor in which 2 minus I current is flowing along the loop. So plus 2 minus I times 20. Now as you move ahead, so there is a 5 ohm resistor that has a current of 2 ohm, and that is also along the loop. So 2 times 5. Okay, so from here we can find the value of I, which comes out to be 4.25 amperes. Well, this can be of some use. This can be used in equation 1 to calculate the value of E, which is required, right? So E is equal to 2 minus I is minus 2.25 into 20 minus again 4.25 into 15, right? So 4.25 into 15. Now this comes out to be E equals to minus 108.75. Well, seems like the EMF, the polarity of EMF should be changed. So it is not, okay, so let me answer it according to the question. So we have calculated the EMF. Is the polarity of the battery correct as shown? No, polarity is not correct because we got a minus. It is not correct because we got a minus considering the prevailing, considering the current orientation of the battery. Okay, so let us move on to part B of the question, which is asking us to calculate how long does it take for 60 joule of thermal energy to be produced in 10 ohm resistor. Okay, so here is the 10 ohm resistor, right? So how long does it take? So the current that is flowing on this circuit is 2 ohm. Now we have three branches here. Let me consider three branches: 1, 2, and 3. And all three branches have equal resistance, right? So because 10 and 20 is 30, 60 parallel is 30, and 30 is itself 30. So the current also divides equally among all three. So the current flowing through the 10 ohm resistor is 2 by 3. Now since 10 ohm and 20 ohm, so this is 10, yeah, since 10 ohm and 20 ohm resistors are in series, so both of these get 2 by 3. So what we can say is the current across 10 ohm resistor is 2 by 3, that is equal to 0.66 or 0.67 amperes, right? And current resistance is 10. So the power is equal to, using the formula, I squared R. So I squared R, so current is 0.67 squared and the resistance is 10, right? Now power is the heat per unit second, because we are asking, the question is asking us the time taken for the production of thermal energy. So what I can write is Q by T equals to 0.67 squared into 10. So, and Q is given, let me separate this. So T equals to, Q is given, how much should be the Q? 60. So 60 upon 0.67 squared into 10, which comes out to be 13.5 seconds. So this is the time that is required to produce that much amount of heat, that is 60 joules of thermal heat from the resistor 10 ohm. So this ends the solution to this question. Thank you for